Okay, so we know that our degree of freedom is 15, and our hypothesis is two-tailed, meaning it is non-directional. So it means we are supposed to read our information here. And our level of significance is 0.05, which is the same as 5%. So it means we are supposed to choose this 5%. It means we are supposed to read our information from this side. So you ask yourself, which of the values should I select when it comes to the third column? Since our degree of freedom is 15, you trace. It means you are supposed to select the value which is around this boundary, and that's what? 2.131. So that's how you read your critical value. So it means that when it comes to this question, our critical value is 2.131. All right. So any question when it comes to how to read the table, and always within the table, make sure that, because we'll be giving several tables, make sure that on top of the table, they have this, especially sometimes you write some selected critical values of T. This is also a t-test, so it means we'll be using the same t-test for that we did for independent t-test and one sample t-test. So it means with all the three t-tests that you've come across, you'll be using one table for it to generate your critical value. All right.
Hello, sir.
Yeah, Obed.
Yeah. So please, would that does that mean with these three t-tests, you always have to use the three means you find the critical value. Like I said, given the critical value,
Yes,
that of
yes, Obed. You're supposed to use the three indicators. That's whether the hypothesis is directional or non-directional, the level of significance, whether it is 0.05 or 0.01, then the degree of freedom.
degree of freedom.
Yes. And the moment you miss any of them, it means that whatever critical value you generate will be wrong. So you need to pay key attention to it. And I use 0.05 because, as I've been saying, when within the question, they are silent. They don't highlight on it that use 0.05 or 0.05. Always assume that your level of significance is 0.05. Okay. So right now we know our critical value is 2.131. Let me go back to my slides and share so that we can continue. So, and I've been saying that first, put your information into writing. Let your reader know how you were able to generate the critical value. And this is how you put it into writing. So the way I've put it into writing, I'm telling my reader that my level of significance is 0.05. It is non-directional, and this is the degree of freedom. And I indicated plus or minus because my hypothesis is non-directional or two-tailed. So I don't know whether it will be positive or negative. The value that I'll be calculating later, whether it will be positive or negative. So since it is non-directional, it means you're supposed to state two decision rules. You state the positive decision rule and the negative decision rule, because you don't know the direction your information will head towards. Hence, you're supposed to state both the positive and the negative decision rule. And there's the format you're supposed to do it. Okay. So that's all for step 3. That's all for step 3. So please, any question when it comes to step 3? Andrews.
Hello, sir.
Yes, go
Sir,
ahead.
please, how did you get the negative, the negative one?
How did I get the negative one?
Yes, please.
But with the positive one, you get the clue as to how I got the positive one.
For that one, I can see that one, but the negative one, I don't know how you come by the negative one.
That's the general rule when it comes to this. So the only thing you need to know is that I don't want to bore with you with a lot of information. Since you'll be stating the positive and the negative, check the signs very well. If you see that when it was retained, it was what? Less than. But with the negative one, when it was retained, it became what? Greater than. So if I were you, I would first try and grasp understanding on the positive one. Even when my hypothesis is formulated in a negative direction, I'll jot the positive one somewhere. Then the only thing I'll do is that I'll change the signs. Let me erase it so that you get it well. You see that the signs are the ones that normally change. And that's what you do. So with a retain, at first it was less than, but this time around, when it was negative, it became greater than. Then with a reject for the positive one, it was greater than or equal to, but this time around it changed to less than or equal to. So try and choose one of them. During examination, when you realize that it is the opposite, you just change the signs, and that's it. Okay.
Hello, sir.
Oh, okay. Thank
Hello,
you.
sir.
Obed.
Yes, sir. Please, the last hypothesis, the reject null hypothesis, if they observe the two, you didn't bring the point, 2.131, you wrote 2.131.
Yeah. Thank you very
So
much.
the points you can.
Yeah. Thank you. Thank you. Yeah. So that's all. Isaac.
Sir.
Yes, sir. In some instances, you realize that when they are stating their hypothesis, they write them together. Can you write them in one sentence?
When you say they write them together, as in?
The negative and the positive, the critical values, the negative and the positive, they write them together.
Good. You can write them together, but if care is not taken, it might confuse you. So in most situations, I prefer to do it separately so that you get a concept well. Now, if you get the concept as to how they write them together, then fine, you can do it in that same fashion. All right.
Hello, sir.
Patrick, please go ahead.
Yeah, sir. Please, from the look of things, per the decision rule, that most of the times is the third step is what worries me a lot. Because per the decision rule, what I've learned and seen here is that they said if the probabilities, or if maybe the whatever is greater than 0.05 decision rule, we are supposed to retain the HO, which is the null hypothesis.
Yes.
And if it is less than or equal to the 0.05 rule, we are supposed to what? Reject it.
Okay.
But here is the case. I'm saying HO rather being less than and being retained. And HO
I
greater
totally
than
get
or
you. Patrick, I totally get you. With that normally comes in, okay, if let's say you use a software, we call it SPSS, Statistical Package for Social Sciences, to do your analysis. Okay. Then with that, you'll be using, when that SPSS will generate an output for you, and that output, it will tell you your p-value. It will tell you where your p-value falls. Then it will compare it with the 0.05. So in that regard, if that p-value that you get is less than the 0.05, then you can say, oh, I am what? I am rejecting HO. But when it comes to the manual computation, we don't compare the value that we generated with the level of significance. You compare it with the critical value. So the critical value here is serving as the level of significance in quotes. So that was why you went ahead to use the level of significance 0.05, whether it is directional or non-directional, and the degree of freedom to generate that critical value. So this critical value is serving as the same rule like if you were doing it on using a computer or a software. So it means you use that critical value and you compare it with the T observed. The T observed is the value that we'll be calculating later. So you are saying that, oh, the value that we'll be calculating later under step 4, if that value is positive and it is less than our critical value, then we are supposed to retain HO. But if it is greater than or equal to our critical value, we are supposed to reject. All right, so that's what you do. So please, any other question?
Please, can I say, irrespective of the test, this is how we should go about it.
Irrespective of the test, this is the rule. This rule runs through all the tests. Just that for you to do this, you first have to know your critical value. Then you compare your critical value with with the T observed using the same signs for the positive and the negative. So please, my main issue is don't confuse the signs. You could see sometimes students confuse when it is positive, they use different signs. Instead of they saying retain HO if T observed is less than, they will indicate retain HO if T observed is greater than 2.131. That's wrong. So that's what I'm saying. In order not to confuse yourself, try and grasp one of them, whether you are trying to understand only the positive one or the negative one. So when you are doing the opposite, you just change their signs. That will help you.
Okay.
All right. So that's when it comes to step 3, if there are no questions. So the next one is step 4, computation. And when it comes to computation for correlated T, it's very simple. It's quite easier than independent t-tests. So this is the computation or the formula for correlated T. So one might ask him or herself, so what is D? Where is the D coming from? You could see within your table, you had these first 3 columns. the first three columns. That was what was provided to you in the question, but I've created additional columns, the last two columns. Trying to what? Trying to solve D. And we also have sigma D squared, also trying to solve D squared. So like what we did for independent T, take D like it is X. So it means you're supposed to find sigma D, which is the same as we're solving for sigma X. So how do we know D? D simply has to do with, you remember one of the assumptions I said you need to find different scores. It means you're supposed to find the difference between the first score and the second score because they are related. They are the same scores. So it means we would subtract 55 from 50. So D is equal to, that's why I've indicated D is equal to X minus Y. D is equal to X minus Y, where X stands for the first score, Y stands for the second score. So you find for each of the pairs. So 50 minus 65, 50 minus 50, then you go on and so on and so forth. So that will be for D. When you are done, then you solve for sigma D. It means you add these values together. So you add and subtract because we have negative values. So you add them together, and when you add, there's the final value that you get, 66. Then the next one, within the formula, you are supposed to find this, sigma D squared. So it means we know D, you are supposed to first find D squared. So for you to find D squared, it will be what? Minus 55 times minus 55, it will give you 25. Then minus 10 squared will be 100 in that order. So you do for all of them. When you are done, then you find sigma D squared. You add them together. And when you add, there's a final value that you get. So at the moment, we've been able to solve for this. We've been able to solve for that. So let's try and solve for n sigma D squared. We know sigma D squared to be what? To be 1098. And we know n. I told you in this course, whenever you see n, n represents the total number of people, and they are 16. So it means the whole of this will be, this side will be 16 times 1098. And that's what we've done, 16 times 1098. And that will give you 17,568. Then within the formula, the last thing you're supposed to do is to find sigma D all squared. Right now, we know sigma D to be 66. So it means sigma D here is 66 squared. So it means 66 squared, which will be 4,356. So when you are able to solve for these values, then the last thing you're supposed to do is to substitute them. So we had sigma D, that's sigma D here. Let me copy this. Okay. So within the formula, we had sigma D to be what? To be 66, which is here. Then n sigma D squared, we had it to be 17,568. Then sigma D all squared, we had it to be 4,356 over n, which is 16 minus 1. Then you solve it systematically. You try and subtract this value from 17,568, which will give you this, over 16 minus 1, which is 15. Then the next thing for you to do is to take away the fraction. And when you take away the fraction, it will be 880.8. Then you find the square root of it. Okay, So when you find, sorry, there should be no square root here. So it should be 66 over 29.6782. Hey, some more. Right. So please, any question? Any question?
No, sir.
Okay, so that'll be the final value. You convert it into 3 decimal places, and that'll be your final value. T observed is 2.224. So when you're done, then you move on to step 5, where you're supposed to compare the T observed, which is 2.224, with the T critical. And right now, we know our value to be what? Positive. So it means you go back to step 3, focus your attention on the positive decision rule, because we had a positive value. So let's compare our positive decision rule. So we indicated that if our T observed is less than 2.131, we are supposed to retain. And if it is greater than or equal to 2.131, we are supposed to reject HO. So you compare 2.224, which is our T observed. You could see that it is greater than 2.131. So per our decision rule, we've indicated that when it is greater than, you are supposed to reject. So since it is greater than, it means you are supposed to reject HO. So that'll be your decision. And this is how you state it. Comparing the T observed with our T critical, it means 2.224 is what? Is greater than 2.131. Hence, reject HO. All right, Isaac, please, your hand is up.
Yes, sir. Please, the final answer.
Okay.
I think it's 2.234 and not 2.224. That when you convert it.
Oh, thank you. So this one is 2.233. Yeah, so it will be 2.234. Thank you. Thank you for correction.
You're welcome.
Okay. All right. So that's what you do. So you are rejecting HO. Then after you've made this decision, then the final thing for you to do is step 6, which is interpretation. And your interpretation will be based on the decision that you've made. And as I've been saying, under interpretation, you are trying to tell your reader that you are accepting one of the hypotheses. And here comes the case, you've made a decision to reject or discard HO. This tells you that you have no other option than to accept which one? H1. Because you've made a decision to reject HO. So it means you have to accept H1. Hence, you go back to step 2, the statement you indicated for H1, where we indicated that type of early childhood social environment. This time around, you know what it is all about. So you wouldn't state it in future tense. It should be in present tense. So the type of early childhood social environment has a significant influence on emotional adjustment. So that'll be all. Winifred.
Yes,
Hello,
sir.
Winifred. Yeah. Please go ahead. Winifred, I could barely hear you.